All right, so I noticed some people were having trouble with trying to figure out how to write domain and range and trying to figure out when the domain is all reals. So I've created this little supplemental lesson which will hopefully clarify some aspects of domain and range. Okay, so first off, let's talk about when to use the curly Q braces for domain and range and when you don't. All right, so let's start off with the curly Q braces. So whenever you use the braces, you're going to look at something that's finite and countable, meaning something that you can list out. That's the only time you're going to actually use the curly Q braces. So these braces here and putting numbers in them is called set notation. And the only time you're going to use these curly Q braces is when you can actually list out the elements. So you use this when you can list them out. So only when you can list out the values. So for example, if I tell you I have a relation that consists of the finite, meaning tiny or endable and countable set of data points that are listed right there. So I have this set of data points and I can actually list out all of these numbers. So if I can list out all of the numbers, then I'm going to use the curly Q braces. So the domain of this relation, because I don't know if it's a function yet, but I can say it's a relation because a relation, remember, is any set of ordered pairs. Since I can list them out individually, I'm going to use the curly Q braces. So I have a 4, a 5, I already wrote the 4, can't write it again. Remember, no repeats, and then 9. So my domain is this, because I can list out all of the numbers. And since I saw a repeated x, I know this thing's not a function. And so then I can list the range out as well. 6, 8, 2, no repeats, I'm done. Okay, so this is when I use the curly Q braces. Remember, no repeats. A graphical example of when I can use the curly Q braces is when I give you a graph, and I'm just going to sketch one right here, that consists of individual data points. Okay, and so let's say this data point here is 1, 3, and this one looks like it might be 3, let's say 1.5, and this is like 5, 3, and this will be like 6, 3. So I just have distinct data points. Nothing's connected, it's just individual little data points. And if I want to find the domain and range of this relation, and since this one actually passes the vertical line test, it's a function, I can list it out with the curly Q braces. So I'm listing out my domain values, which are 1, 3, 5, and 6. And then I can list out my range values in the curly Q braces. They are 3, repeated, not going to write it again, and then 1.5. Okay, so that's when I use the curly Q braces. The time I would use the curly Q braces, or the just regular braces, as they're not really, curly Q and braces is redundant, is when for equations, is when I give you a limited domain. Okay, so whenever you have an equation, if I don't specify a domain, if I don't tell you that the domain is, for example, on that homework, the integers from -2 to +2 inclusive, if I don't specify something like that, or if I don't tell you ahead of time that the domain is a certain set of numbers, then you don't assume that there is a limit on the domain, and the domain becomes any number that works for the equation. So the only time you're going to use the curly Q braces for domain or range for the equation is when I tell you ahead of time that there is some kind of limitation on the domain. In this case, I'm telling you the domain is just these 3 numbers. So when you figure out the range for this one, you would write it in curly Q braces because I have distinct data points that I can actually list out. And so the range for this is -6, 3, and 0. Okay, so if I give you an equation, just some equation, and I don't tell you anything's limited, then you use any value that works for x as the domain. If I give you the domain specified out like this, or if I say something like this in sentences, like I say the integers from 0 to 4 inclusive, then you would use the curly Q braces. Otherwise, you're going to use the symbols, which is what we're going to talk about now. Okay. So I use the symbols, meaning the less than, the equal to, the set of all real numbers, when I have something that I can't list out. So for example, if I just give you some generic equation like I say, f of x equals 3x squared plus 4, and that's it, then your domain, you have to think about it's the real numbers that work for the equation. So you have to look at the equation, and if you remember what we talked about in class, I said the equations that we study in Algebra 1, every real number works. And if I think about it, I can square any real number, I can multiply any real number by 3, and I can add 4 to any real number. So this thing's domain is the set of real numbers. Now this symbol means the set of real numbers, so you do not put it in curly Q braces. It is redundant to put the curly Q braces on it, because this symbol literally means the set of real numbers. And whenever you use the curly Q braces, you tell a mathematician, hey, I'm about to give you a set, but this is already a set. So you would just write it like this. Now for the range of this one, I'm going to use what I know from transformations. I know that this is a parabola, and since it has a 3 in front of it, it's going to be thinner, which does not affect domain or range. There's no negative symbol, it's a positive x squared, so it's going to be a happy face parabola, and that plus 4 meant it was the parent moved up 4. So if I do a quick sketch of this, it's going to be skinny, moved up 4, and it's going to be happy face. So that lowest value of my parabola is at 4, and for this one, my range are going to be the y values that are greater than or equal to 4, because I cannot list out every single number that's greater than or equal to 4. You know, it's 4, 5, 6, 7, yeah, those integers, but it's also everything in between those numbers. And so when I get a graph, I have to be very conscious of what I'm given. So for example, let's say I have this graph, and I'm just going to sketch something really quick, and I'm putting in the asymptote, and I'm going to tell you that's going to be y is -2, and I give you this graph. Now I have to be very conscious of what's going on in the graph. It's all in the details, kids. Algebra is not necessarily a big concept thing. It's all in the details. So I look at this, and I see the arrows, and the arrows tell me this graph goes on forever. And it's a smooth curve. There are no breaks, there are no holes, and it happens to be an exponential. So I know the domain is going to be all real numbers. And you can say equal, or you can use a colon, doesn't matter. So it's all real numbers, because that's the domain of the exponential functions we study in Algebra 1. But if I look at the range, I'm looking for the y values. Now, it's going to go off to infinity on the y values, but it's one of those exponentials, so it's going to approach this dotted line and never actually be the dotted line. And so the range is going to be y is strictly greater than -2. All right? So you have to be very conscious of what's on the end. If I didn't put any endpoints on there, then that's a problem. I'm either going to put arrowheads or endpoints on there. So, and it's a smooth curve. And whenever you connect the dots and you make this smooth curve, you're telling everybody that I want every single data point, not just the ones on the integers. I want all of the ones in between too. So I'm going to get an x value of pi, I'm going to get a y value of pi, I'm going to get like the square root of 2 and the square root of 3. Those kind of numbers are all in here, and I can't list those all out. So I have to use the symbolic representation for those. And when I said be very conscious of what your endpoints are, remember I can give you pieces of functions too. So I can give you like a piece of a line. So this is not the full linear function, this is just a piece of it. So let's say that data point there is 4, 10, and let's make this one, looks like, let's say 12, 2. Let's just make up some numbers here. So when I find the domain and range of this one, I have to think about these endpoints, because this doesn't go on forever. However, I can't list out every single number either. The domain's not 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a connected line. That means I want all of the in-between values too. I can't list them all out. It's not every possible number, but I can't list them all out. I can tell you where they start and where they begin. And so my domain starts at 4, ends at 12. And domain, remember, are the x values. And it can include 4, so I'm going to say less than or equal to, but it excludes 12, so it says less than. So this tells everybody, hey, you know what? My domain is every single number between 4 and 12 that includes 4, but does not include 12, and that's exactly what my picture shows. All right? So I can't list those numbers out. I can't list out the numbers in between. And whenever you can't list out the numbers in between, you got a smooth line that's connected, or you get an equation where I don't tell you that something's limited. All right, now for the range, I do the same thing, but I swap x with y, and instead of looking at 4 and 12, I'm going to look at the y values. So the lowest part of this graph is here at 2, the highest part of this graph is here at 10, so it's going to be between 2 and 10. Remember, low value to high value, and the low value for y is exclusive, does not include, so it's strictly less than, and the 10 is inclusive, for it's less than or equal to. So, to recap, I'm going to use the curly Q braces when I can list out everything because I have distinct data points, either in a set, on a graph, or I tell you the equation has some limiting factor going on, either in sentence form or written as a set itself. And then I'm going to use the symbols, the set of real numbers, when I give you an equation with no limits. Okay, and well, where the real numbers all work, which is what happens in Algebra 1. And then the range, I'm going to use the symbol that matches what goes on with the y values. In this case, it's a parabola that opens up, it starts at 4, so it's going to be y is greater than or equal to 4. The exponentials, remember, don't have or equal to, so if I give you this graph, it's connected. I want every single point on this graph. Domain is all reals, range is y is strictly greater than -2 because that exponential will never, ever, ever, ever be -2. And then when I give you a piece of a graph, I have to be very aware of what the endpoints are and whether or not they're included. Solid means included, open means excluded. This goes from 4 to 12 on the domain. I want 4, I don't want 12, I write it like this. This tells me every number in between 4 and 12 that includes 4. And then I do the same thing with the y values. It goes from 2 to 10, 2 to 10 on the y, does not include 2. Totally includes 10. And so I'm going to use those symbols. So hopefully that clears up how to write domain and range.